My name is Turgesh Abhishek Analaki Arularasu, matrix number S75261. Today, our group will present an analysis on electric vehicle (EV) battery supply chain in China and its related policy issues and environmental impacts. As the world moves towards a low-carbon economy, electric vehicles have become a key solution for reducing greenhouse gas emissions and promoting sustainable transportation. At the center of this transformation are EV batteries, which play a critical role in powering clean energy technologies. China has emerged as the global leader in the EV battery industry, dominating mineral processing, battery manufacturing, and recycling activities. However, while China's leadership has generated significant economic growth, technological innovation, and employment opportunities, it has also raised concerns regarding environmental degradation, resource scarcity, labor rights, and geopolitical dependency. Therefore, this presentation examines the EV battery supply chain in China through various economic theories and evaluates its economics, environmental, social, and ethical impacts. We will also discuss key policy challenges and propose recommendations to improve the sustainability and resilience industry.
Good day, everyone. My name is Muhammad Arifikuan bin Zube, and my matrix number is S74258. Today, I will explain section 2.0, which is the application of economic theory in China's EV battery supply chain. First, let's look at externalities and environmental economics. Electric vehicles help reduce air pollution and carbon emission, which benefits society. However, mining materials such as lithium and cobalt can cause water pollution, soil damage, and greenhouse gas emission. Therefore, government policies such as environmental regulation and recycling incentives are important to reduce these negative effects. Next is resource economics and scarcity. EV batteries require critical minerals like lithium, cobalt, and nickels, which are limited resources. China has secured a strong position by controlling the refining and manufacturing stages of the supply chain. While this brings economic benefits, it also raises concern about resource depletion in the future. The third one is industrial policy and comparative advantage. China has become a global leader in EV batteries production because of government support through subsidies, research and development, and industrial policies. This effort have helped Chinese companies become more competitive and innovative. The fourth theory is trade and global value chains. The EV battery supply chain involves many countries. Raw materials are sourced from different regions, processed in China, and then exported worldwide. By controlling the higher value stages of production, China gains a larger share of the economic benefit. Finally, growth and green transition. China invests heavily in battery technology, recycling system, and innovation. According to endogenous growth theory, technological progress is a key of long-term economic growth. This investment helped China strengthen its economy while supporting environmental sustainability. In conclusion, economic theories help explain China's success in the EV battery industry. Although the industry provides economic and environmental benefits, challenges such as resource scarcity and environmental impacts still need to be addressed to ensure sustainable growth. Thank you. That's all for me.
Good day, everyone. I will explain the impact analysis of China's EV battery supply chain. First, for the economic impact, the industry creates more jobs, increases export, and promotes technological innovations. However, it also depends heavily on raw material like titanium and cobalt, making them vulnerable to price changes and supply chain disruptions. Second, for the environmental impact, EV batteries help reduce carbon emissions, support renewable energy, and encourage battery recycling. On negative sides, mining and battery productions can deforestation, water pollution, and battery waste. Finally, for the socio-cultural impact, the industry improves public health, creates skilled job opportunities, and develop infrastructures. However, it may also displace local communities and increase social inequality and expose workers to health and safety risks. Overall, China's EV battery supply chain brings many benefits, but managing these challenges is important for long-term sustainability. Thank you.
Good evening, everyone. The EV battery supply chain faces three major challenges: labor rights, environmental damage, and geopolitical risk. First, many battery minerals such as cobalt are sourced from developing countries where workers often face unsafe conditions, low wages, and in some cases, child labor. Second, mining and refining lithium, nickel, and cobalt can cause pollution, water contamination, and health problems for nearby communities. Finally, the global EV industry depends heavily on a few countries, especially China, for processing critical minerals. This concentration creates supply chain vulnerabilities and geopolitical tensions. Addressing these issues is essential for a truly sustainable EV future.
A very good afternoon to the doctor. I'm Skanda, matrix number S75367, and today I'll be presenting our key decision and also the recommendation and strategies for improving China's EV battery supply chain. So right here, the first one is improve EV battery supply chain policy. Our first decision focuses on improving recycling policies. Currently, China controls 76% of the global EV market and 70% of the battery production capacity. However, the recycling sector faces challenges, where with over 40,000 licensed recyclers compared to only 156 official MIIT recyclers, where 99.6% of them use batteries as recycled through unregulated channels. So for the solution for this matter is to implement stricter recycling standards. For example, the MIT's 2024 draft regulation proposes recovery rates over 90% for lithium and over 90% for nickel and cobalt. Research shows China could achieve lithium independence by 2040 through efficient recycling. For decision making 2 here, which is to continue with the social impact to the EV battery supply chain policy, where the EV battery industry has created over 50,000 recycling jobs and provides cleaner transportation for millions. However, we must also address gaps in formal recycling practices. For example, we need extended producer responsibility to prevent manufacturers from externalizing environmental costs. This also includes battery standardizations, carbon labeling, and also transparency reporting to help consumers make informed decisions. Well, the key improvements needed overall here is to enforce safety standards, exclude informal businesses, and also to provide affordable energy storage to low-income communities. Well, for the next point, which is the recommendations and strategies. So now let me share our main 3 recommendations. So it's second life battery standardization. We have critical minerals diversification with domestic battery chemistry innovation. And also the last one is mandatory extended producer responsibility EPR with national battery passport system. So for the first one, our first recommendation is to standardize second life battery applications instead of immediately recycling used EV batteries that can serve approximately 5 to 10 additional years in energy storage system. So this is recommended by establishing national technical standards for battery health evaluation and also to standardize the battery modules for integration into 5G base stations. Well, for the second strategy here, so second recommendation or strategy addresses mineral dependency, where China currently processes 85 to 90% of global lithium, cobalt, nickel, and also graphite, which are all components for the batteries. Specifically, investment in this point, it's mostly for research and development, while developing sodium-ion battery technology reduces reliance on both lithium and cobalt. For the last point here, which is for the mandatory extended producer responsibility with national battery passport system. So this, so currently in China, this EPR policy is actually weak, where manufacturers only need to provide battery details without enforcement mechanisms. A digital battery passport will track each battery's entire life cycle from production up to disposal. This ultimately prevents manufacturers from externalizing waste management costs to communities and reduces hazardous environmental damage. Well, in conclusion, these strategies so far that it's been listed here and also from academic research as well will most probably create a more sustainable, resilient, and also a socially responsible EV battery supply chain for China. And that's it. Thank you.
In conclusion, China's EV battery supply chain has become a vital pillar both the global energy transition and China's economic development. Through strong industrial policies, technological innovation, and strategic control of the global value chain, China has established itself as the world's leading EV battery producer. This leadership has contributed to job creation, export growth, technological advancement, and increased industrial competitiveness. Despite these achievements, the industry continues to face major challenges including environmental impacts from mining and refining, dependence on critical minerals, labor right concerns, and geopolitical risks. These issues demonstrate that economic growth must be balanced with environmental sustainability and social responsibility. To ensure long-term sustainability, our analysis recommends strengthening battery recycling systems, increasing producer responsibilities, expanding second life battery applications, and investing in innovative battery technologies. These strategies can reduce environmental impacts, improve resource efficiency, and strengthen supply chain resilience. Ultimately, a future success of China's EV battery industry depends on achieving a balance between economic efficiency, environmental sustainability, and social responsibility. By doing so, China can support its carbon neutrality goals while contributing to more sustainable and equitable global energy transition.